So for the next section, the standard deviation calculation, we're asked to calculate the standard deviation of our PV measurements. So far we've done this using Excel or a calculator, but this actually requires us to step through the various different steps in order to calculate the standard deviation by hand. In order to do this, I'm going to have a set of simple sample data for us here to just kind of illustrate what exactly is happening in these steps. So we're going to start off with just 1, 2, 3, 4, and 5 as our sample data. And the very first thing that's going to be asked of us is going to be to calculate the average. So our average x bar is going to be equal to the sum of all of our data points up here divided by n, which is going to be the number of measurements. So we have 1 plus 2 plus 3 plus 4 plus 5 divided by 5 because there's 5 different measurements. If we add all these together, we get 15. We divide that by 5 and we get 3, which actually makes a lot of intuitive sense because 3 is the middle of this data set, and that is pretty much what the mean is going to give us a sense of the central tendency of our data set. Next, if we take a look at the standard deviation, we see this icky looking little formula right here that seems pretty intimidating at first. But so long as we just break it down and go through the order of operations, it's really not that bad. And that's what this lab is really designed to do. So the first thing we're going to do is we're going to calculate something they call the deviation. And you see that they say it equals PV minus the mean, and it has units of pascals times milliliters. And in our notation up here, this is essentially xi minus x bar. It's just this little piece right here, okay? And what we're going to do is we're going to take the mean that we calculated before, 3, and we're going to subtract that from each one of our points. So we have 1 minus 3 is negative 2. We have 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. And 5 minus 3 is equal to 2. The next part that we're asked to calculate is going to be what they call the deviation squared. We're getting units of square pascals times square milliliters. And this is going to be stepping out from this a little bit, this central piece with the square on it, looking like that. And what we're going to do is we're just going to take this part that we've already calculated and we're going to square each one. So we wind up getting negative 2 squared is 4, negative 1 from here, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is equal to 4. The next step of our calculation, we're going to be summing up the square deviations. This is where we're going to handle this sigma notation here that may be confusing to all you guys. So what this basically means right here is to just sum up all of these quantities xi minus x bar squared that we've already calculated. So for that, we're just going to take the values from before, 4 plus 1 plus 0 plus 1 plus 4, and we're going to see that that is equal to 10. Next, we'll divide the sum of the square deviations that we just calculated by n minus 1. We had n of 5 like we saw in the average. So we're going to take our previous value of 10. 5 minus 1 is going to be 4. We get 10 over 4, and that's going to equal 5 halves. The next step is to take the square root of the above number, and at that point we have now completed all of the steps and orders of operations for the standard deviation, and we will arrive at our final answer. So the square root of 5 halves is what our answer is going to be. For simplicity's sake and to give myself a break on the significant figures, I'm going to say that this is approximately equal to 1.6. If we want to visualize what this basically means, is that we're going to have a set of data where our central value will be 3, and we're going to have a span of plus or minus 1.6. So you can see it's not going to quite reach the highest data point in our set. It's not going to quite go to the bottom data point in our set. And it's going to have a span of twice the standard deviation. So our min value, therefore, is going to be this central value 3 minus the 1.6, or 1.4. That would be this point right here. Okay, and our max value would be 3 plus 1.6, 4.6, which is this value right here. And after performing that last bit of calculation, you guys will be done with this lab.